This video is going to cover Chapter 6, Section 1, and we're going to talk about angles and their measures. So in Chapter 6, it's going to be just like the Chapter 5 that we just finished from the Brown book. What's going to be different here is we're going to change the measurement. We're no longer going to be measuring angles in degrees. We're now going to measure them in radian measure. So what'll be important here is whenever we do any of the calculator questions, you need to make sure that your calculator is in radians. So the same way that you changed it from radians to degrees, now you're going to go back and change from degrees to radians. When we're sketching the angles, we're still going to sketch them the same way that we did in Chapter 5. They're still going to have the same starting point, the initial side, and then they'll have a terminal side as well. The only difference is we're going to measure them in radians. So let's first define what a radian measure is. And 1 radian is the measure of the central angle theta that intercepts an arc S equal in length to the radius r of the circle. And here is our formula. Theta is equal to the arc length, which is S, divided by the radius. Or, if we rearrange the equation, the arc length is equal to theta, the angle measure in radians, times the radius. Keep in mind that 1 revolution around a circle of radius r, that corresponds to an angle of 2 pi. So before, 1 revolution around would be 360. Now we're going to measure it as 2 pi. So let's take a look here. So what we saw in the previous chapter, we saw that over here was 0 and 360. Now what we're going to see is this is going to be 0 and 2 pi. Up here at 90 degrees, this is going to be pi over 2. And we're going to learn the formula to convert between degrees and radians to degrees. Over here, this was the 180. So now it's going to be pi radians. Down here at the 270, this is going to be 3 pi over 2. Now, the location of 1 radian, it's about here. And 1 radian is equal to about 57 degrees. So approximately 57 degrees. So this would be about the location of 1 radian. 2 radians, about here. 3, it's almost pi, so this would be 3 radians. 4 radians are located down here. 5 over here. And lastly, 6 over here. Because if you think about it, 2 pi is equivalent to 360 degrees. And 2 pi, if you think about the approximation for pi, 2 pi is approximately 6.28. So just over 6 radians is an entire circle. Now, just like we did in Chapter 5, we're going to be able to find coterminal angles. Before, what we did was we added and subtracted 360 degrees, which was a full circle. Now, when we measure in radians, a full circle is 2 pi. So we're going to be adding and subtracting 2 pi, 1 full revolution around the circle, in order to find coterminal angles. Okay, so again, 1 revolution around a circle of radius r is going to correspond to an angle of 2 pi. Because remember, theta is equal to S over r, 2 pi over r divided by r equals 2 pi. So let's try some examples of finding coterminal angles. So it wants us to find a coterminal angle for 17 pi over 6. So just like before, let's go ahead and let's find a positive coterminal and a negative. So notice, now you're going to learn how to convert this. to degrees and from degrees to radians. The formulas we're going to learn in this chapter, all angles need to be in radians. So if you're given an angle in degree, you will have to convert it. I know we haven't seen it yet, but 17 pi over 6, this is equivalent to 510 degrees. So just by subtracting 2 pi, I'm still going to have a positive coterminal angle. Now, here's where our skills of adding and subtracting fractions are going to come into play, because I need to find a common denominator. My common denominator is going to be 6. So I'm going to change 2 pi into 12 pi over 6. And now I can subtract, and I have 5 pi over 6. And this is a positive coterminal angle. And just for future reference, this is equivalent to about 150 degrees. So if it asks you for a negative coterminal angle, just like before, we would still have to subtract 360 one more time. So let's go ahead and do that. So I'm going to take the 5 pi over 6, subtract 2 pi. Now remember, we already found the common denominator. So instead of putting minus 2 pi, I'm just going to put 12 pi over 6. And my negative coterminal angle would be negative 7 pi over 6, which is equivalent in degrees to negative 210. Let's try another one. Now, they're giving us a negative angle. So in order to find a positive coterminal angle, I need to add 2 pi. So again, I need to find a common denominator. My common denominator is going to be 3. I'm going to change 2 pi into 6 pi over 3. And now I can add and 2 pi over 3. This would be my positive coterminal angle. Again, this is negative 240. And then this one is 120. Then if I wanted to find a negative coterminal angle, I could have taken my original one and subtracted 2 pi. So subtract 6 pi over 3, and I get negative 10 pi over 3, which is equivalent to negative 600. Because again, remember, the 2 pi is 360. So all we're doing is adding 360, but we're doing it in radians. Now, the next slide actually has the formula for converting degrees to radians and radians to degrees. Go ahead and take a look at that formula. Now, keep in mind that 1 degree is equivalent to pi over 180. And 1 radian is equivalent to 180 degrees over pi. And that's how we get our formulas. So to convert from degrees to radians, you would take your angle measure, that would be in degrees, and then multiply it by pi over 180. If you want to convert from radians to degrees, the angle measure theta would be in radians, and then you will multiply it by 180 over pi. Keep in mind some common radian equivalent measures. 360 degrees is equivalent to 2 pi radians, and 180 degrees is equivalent to pi. And we saw that when I filled in the axis points and showed you where the radians were located. So let's go ahead and practice converting. Now, when the instructions say to convert and leave your answers exact, then that's when you're going to leave it in terms of pi. If they ask us to give us an approximation, that's where we will use our calculator and we would press the pi button. So all of these we're going to convert we're going to convert the angle from degrees to radians or vice versa. So the first 3 examples, or actually the first 4 examples, they're given to us in degrees. So remember, the conversion to go from degrees to radians is I'm going to multiply the degree measure, theta, by pi over 180. Now, if it says to give the exact, and that's what I want to see here, then we're just simplifying the fractions here. So I could simplify 135 and 180, and I can simplify this to 3/4. So 135 degrees is equivalent to 3 pi over 4 radians. 540, same formula, 540 times pi over 180. Again, I can simplify. 180 goes into 180 once and into 543 times. So the final answer here, or the equivalent for 540 degrees, is 3 pi radians. Next, 45 degrees. Again, same thing. We're multiplying it by pi over 180. And 45 actually goes into 180 evenly 4 times, and it goes in here once. So 45 degrees is equivalent to pi over 4 radians. One more conversion from degrees to radians, then we're going to go the other way. 90 degrees, and this is one that you should be familiar with. 90 times pi over 180. And then 90 goes into 180 twice. 90 into once. Pi over 2 radians. Now we're going to convert the other way. 7 through 11, these are all given in radians. So let's test it out. Now, if there's no degree symbol, then it's understood that the angle measure is represented in radians. So let's go ahead and take our first look at the first one, 5 pi over 6. The formula to convert is I'm going to multiply by 180 over pi. Notice the pi's cancel. I can also simplify the 6 and the 180, and this becomes a 30. Now I'll multiply what remains, and it's 150 degrees. Next, again, we're going to multiply it by 180 over pi. Again, the pi's cancel. And also the 4 and the 180 can also simplify. And the 180 becomes 45 and the 4 becomes 1. Multiply what remains, 3 times 45, and it's 135 degrees. Now, just to take a look at the one up above, the 45 degrees, let's see if this makes sense. So this is the exact answer. However, if I wanted to give an approximation for this, what I would do on my calculator is pi divided by 4, which gives me approximately 0.7854. Now, if you recall back from that very first slide, remember 1 radian is about here, and it's equivalent to about 57 degrees. This 0.7854, this is approximately equal to 45 degrees. So this makes sense. If 1 radian is 57 and 45 degrees is 0.78, it's almost, it's a little bit less than 1, so it does make sense. So let's keep going. Let's do some more conversions. I now have negative pi over 2. Again, I'm going to multiply by the conversion, which is 180 over pi. Again, my pi's will cancel, and I can divide 2 and 180, and this gives me negative 90 degrees. Because this simplifies and becomes a 90. Now, again, if there's no degree symbol, you're assuming that these are radians. Remember, 5 radians is located down here in the 4th quadrant. So let's go ahead and let's see what we got. Let's go ahead and convert it. So to convert, I'm going to multiply by 180 over pi. And now this becomes 900 over pi. And if I were to divide this, I would get 286.48. And again, remember when I drew it initially, 5 radians is about here, and that's where 286 is also located. So again, it makes sense. Let's try one more. 2 radians, we'll multiply it by 180 over pi, and I get 360 over pi. Again, this would be the exact answer. The approximation, you would divide it using your pi button, and it's about 114.59 degrees. And again, it seems to make sense, because again, if you draw it, 1 radian is here, 2 is over here, and notice 114 degrees would be in quadrant 2. So again, it does make sense. Next, we're going to learn how to calculate an arc length and an area of a sector. So again, the arc length is usually represented by the letter S. The R in both of the formulas represents the radius. When we go to calculate the answers for the arc length and the area, theta must be in radians. If it's not, then we'll do the conversion that we just did in the previous slide. So let's try an example. It says a circle has a radius of 18.2 centimeters. Find the arc length and the area of the sector. So again, if we, so what's given here, my radius is R, and it is 18.2. And again, theta is given to me in radians, so I'm good. I don't need to convert anything. Remember, the formula to find the arc length is going to be radius times theta. So I'm going to do 18.2 times 3 pi over 8. And again, this is going to be an approximation. So it's approximately equal to 21.4 centimeters. So this is a piece of the circumference. Next, we'll do the area of the sector. So the arc length is like the crust of the pizza, and the area of the sector would be like the whole piece of pizza itself, the area that covers. So again, the formula for that is 1/2 radius squared times theta. So 1/2 18.2 squared times theta, 3 pi over 8, approximately equal to 195.12 centimeters squared. Let's try one more example and we're done. Now for this one, notice the radius that they gave us is the same, but this time they gave us theta in degrees. Remember, theta must be in radians. Now when I go to do my formula, my arc length is equal to radius times theta. Right within my formula, I'm going to do the conversion. So again, remember my radius given to me was 18.2. Theta was 144. And I'm going to do the conversion here. I'm going to multiply it by pi over 180. And again, this will be an approximation. So my arc length is approximately equal to 45.7 centimeters. And then the area of the sector, and again, I have to do that conversion, 1/2 radius squared times theta, 144 times pi over 180, gives me approximately 416.25 centimeters squared. And that is it for section 6.1. This should honestly be a review of what you did in geometry. Because in geometry, we did the conversions of degrees to radians or radians to degrees, as well as finding the area of the sector and the length of the arc. So that is it for 6.1. You do have a web assignment, and it is due tomorrow. Have a great day.